Okay, hey everybody. This is the start of Chapter 8 notes, and we'll do some live coding in these notes. Chapter 8 is a unit on object-oriented programming. And this is an exciting unit, I think. It builds on a lot of the stuff that we started talking about even in like the first unit of Programming 1 when we started talking about turtles. And it also is a great transition if you're looking forward to taking AP Computer Science someday. As the Java programming language you'll learn in AP is an entirely object-oriented programming language, and you'll rely heavily on some of the concepts we work with this unit. Right, so for this unit, to get set up and ready to go, you are going to want to fork the starter code, which you'll find in the Chapter 8 modules of our Canvas page. Right, so go ahead and fork yourself a copy of this Replit starter project. And this will have all the code you'll need for this unit. And it should already have simple critter as the first Python file it imports. And that's the file that we'll work with today. So if you want to open that up, you can even put your name on it. Let's see, 23. All right. All right, or object-oriented programming, all right, sometimes referred to as OOP, is a new style of programming, a different style of programming than we're used to. So far, we've been doing things more or less procedurally, with some like subroutines built in, because now we know how to do functions. So we might include a function that bundles some code together. But for the most part, our programs have been procedural in the fact that it goes from top to bottom and kind of executes as we need to execute. Object-oriented programming complicates this a little bit, but it does it with a really worthy goal in mind, is that it's going to make these more complex programs, more complex concepts easier to model with software. And it does that by creating these software objects that contain both data and operations. We'll refer to these most often as attributes and methods. This is widely used. It is, as I said, it's the base of many programming languages, including Python. Even though in Python, it's not strictly enforced that you use object-oriented program when you write your program, but at the most fundamental layer, Python even is an object-oriented programming language. Right? The data types that we work with in Python are objects. So, and like I said, the cool thing is that we've been dealing with objects all along. It's just we haven't designed our own objects. So now that's what we're going to get a chance to do this unit. Um, um, so with these objects, we'll be able to create these software things that might behave or interact like real world objects. And that's kind of what we'll model them after. So there's a great example on your screen of this, from what we know so far, right? So we know like turtles, and we know turtles can do stuff and they can change in different ways. So if you create a turtle, right, you can maybe change the color, or you can put the pen up or the pen down, and you can move the turtle around and draw with the turtle. And as you're doing these different things, you're running methods on the turtle object to achieve your goal, right? And as you're running these methods on the turtle objects, like their traits, the characteristics of the turtles change, right? The attributes of the turtles, like their color might change, their shape might change, their position might change as the program executes. The other nice thing about turtles is like all we need to create a second turtle is just to call our turtle class a second time. All right, so we'll continue to use turtles as a kind of like a shared experience that we can build off of. So these classes that we're going to need to use can be thought of as like a blueprint or a template that allows us to create these software objects. Um, the name of our classes need to be capitalized, and that's by convention, but you want to make sure you stick to that convention. Uh, and when we create an object from a class, it's known as an instance of that class, and then is said to be of the type of that class. So in the code example here, we can see that the capital T turtle class is called to initialize, right, instance of class turtle, right, which is our crush here. This first turtle, by the way, is referring to the turtle module that we had to import, right, to even access the turtle code. So all the turtle code is bundled here, and then the turtle class is one piece of that code that allows us to create these turtle objects. Right, so in this case, crush is an instance of class turtle. Crush is said to be of type turtle because it's a turtle. Um, Same thing for the Squirtle object here, right? Same idea. So if we're going to go and create our own class, we need a capitalized word that we can call and create objects from, right? So we're going to use this new keyword called class that will let Python know we're about to define our own custom class, right? So same way we defined our own custom functions, we're going to use a class definition where we're going to write all the code that defines our class that will define our objects. So the scope of this class, just like most things in Python, is defined by indentation. So anything indented in this class keyword is going to belong to our class, right? Similar to functions. And then also similar to functions, you'll have to end the statement with a colon, right? For your class header, which is the very first line. You can see that a docstring is also included here for the class, similar to a function. Right, now when we go to create a new object from our class, in order to do that, we need to have a special method known as a constructor included as part of our class. So the first thing we'll learn about defining classes is we'll define this constructor method. It's special, right? You have to name it def double underscore init double underscore self. It's an initializer method, and we'll refer to it as a constructor. And it's special because it will automatically be called or invoked when a new instance of your class is created. So this example here is from your online textbook, this idea of a class point, where a point is going to model, if you look back a second, it's going to be a template for creating, representing, and manipulating a set of x, y coordinates. So it's just modeling a point in a like a coordinate plane. So if we want to do that, we would need to keep track of what are the x and y coordinates of this point. And in order to do so, we'll need to include those as attributes of our point object. So for right now, we're going to kind of gloss over this a little bit, but just know that whenever we create a point using this constructor, it's going to create the point at the origin, which is going to be 0, 0. So 0 in the x, 0 in the y, right? So our constructor will create these points for us. And when we call our class point, right, notice the capitalization on point, it's going to instantiate a new object of type point. Right, now that we have a point class, we can create as many points as we want by just continually calling our capital P point class. Now, at this point, all of our points, you may realize, are going to be at the origin point, so 0, 0. So if we look at this example from the code, a visualization of the code we just looked at, both the P and the Q point objects look pretty much the same, right? They have these x, y coordinates, and they're both initialized to the origin point of 0, 0. All right, we're going to define our own class here in the notes. And instead of point, what we're going to do is create what we're going to call a critter class. Right? And there's some notes already in here about what are objects and classes and how do you define a class. But we're going to go ahead and just start by defining our class. All right, so our class is going to be class critter. So we just wrote the class header, always the first line of a class definition, and then we're going to include a doc string, noting that a critter is a virtual pet. So this is a software pet that we can, take care of, or do things to, or make speak, or do various things. And you can think of that like if you're familiar with like the like virtual pets, Tamagotchis from like the 90s. They were like these little keychain pets, right, that you could carry around with you. They had like little buttons that you could click to like do different things to like feed them or make them sleep. Um, and the idea was you had to keep your little virtual pet alive. So it's kind of what this is, right? It's just a software representation of that. Okay. So with the class critter, we're going to define a constructor. As noted, every class should have a method, right, with the special name double underscore init double underscore. So this method, this initializer method, often referred to as a constructor, is special. So it's a special method. And it will automatically be called whenever new instance of a class is created. So here's how we define our constructor. And notice I almost just made a mistake. And this is really common when you start writing classes. The method I was about to start defining is actually now outside of my class. I need to make sure that all the methods and all the attributes that go with our class are actually part of the class. So they need to be indented to one level. So I'm going to define this custom critter class, right, by including this constructor. I'll just note that this is the constructor of the critter class. And when this critter is born, like when you create a new critter object, I'm just going to say a new critter, maybe we'll capitalize that, critter has been born. We don't often print inside of a class definition, but in this case, just so we can see stuff as it happens, we're going to do some printing. And we're also going to define an age. And again, we'll talk more about this um, later. But for now, we're just going to say every critter, like when they're born, they're age 0, right? So we'll just set our critters to be age 0. All right, now we're defining this class critter, but we haven't used it yet. All right, so similar to functions, there's this difference between definition and usage. So we defined what a critter is, but we don't have any critters yet. We actually have to go down and create critters. So we're going to go ahead and create instances of class critter. Let's create a couple critters. I'll create our first critter, crit1. Um, and then I'll create a second critter and call that one crit2. So we have two instances of class critter. Right? These variables are of type critter because they're storing our critter objects for us. So we'll just note this. We'll say crit1 is a variable reference to a critter object. So this variable here, this is the variable that gives us access, or it's a reference to the actual critter we created, right? So for all intents and purposes, you can just think of crit1 as your critter object. And then we'll go ahead and note that this is a separate second critter object. Okay. All right. Oh, looks like I misspelled. All right, so when we create these critters, we print it in the constructor. So we should see in output, right, the birth of these critters. Let's see what happens when we run it. Awesome. So in the console, if you can see this, it says a critter has been born. It says it twice, right? Um, so yeah, yeah, nice. All right, so next step, we are going to show you how easy it is to, the power of a class, right? Is that now it's like super easy to to um, to create objects, and then as we add more information to our objects, all of these objects will get all of that information. So wanted 500 critters for some reason. Do that, right? Just create a loop to create all these critters, and then now we have tons and tons and tons of critters. Right, so now it's very easy at this point to create these objects. All right, so let's scroll back up. We are going to add a method to our critter. Right, so before your main now, right, inside your class, so make sure you're indented a level inside your class. We're going to define a method called talk. So we just go ahead and type this out. And the talk method is just going to make the critter say something. So let's go back to our slides for a moment. All right, so we're going to come back to attributes. We're going to skip ahead and look at methods. Um, or no, I take that back. Let's just briefly look at attributes. So an attribute when we're referring to a class is the data associated with the object. We sometimes call these attributes instance variables. You hear that term um, as well, but we're going to try to use the term attribute for the most part. And often the constructor is the location where these attributes are set up, all right, which makes sense, right? Because if you're going to create an object with a constructor, right, it would make sense for that object to be created with like the information that makes that object unique, right? So in terms of a critter, right, we might have some things we want to set up for critters. So we said the age is 0, but like what else is a critter? What else defines a critter, right? We get to decide that. So we can make the critter, give it a name, give it a color, give it whatever you want to give it. You can make your critters um, however you would like, right? Um, and this parameter that we've seen and typed already, this self parameter, is the way that we reference our individual objects. Right? And this is a very abstract concept, and this one is hard to wrap your head around when you first see it, and it will take time, right, before you really understand the use of this parameter likely. So it's a convention. You don't have to call it self. It could be any variable name you want. But again, like with most conventions, we need to stick with it because that's how everyone's going to know what we're talking about. Um, all right, so this variable, as it says, is a variable that is automatically set to a reference of the newly created object. So you can see in our example here, the self variable for a point object is the first, and self is always the first parameter defined. But when you call a point, if you look down below here, there's only 2 arguments passed, right? As opposed to the 3 parameters defined. And that's because this self parameter is implicitly passed. Like when you create a point, a reference to the point object you created is passed into the constructor, right? And that's because like when I'm talking about a point in my class, remember a class is like defining all points. When I'm defining all points, I need some way for when we call the constructor, in order for it to like know which point needs to be constructed, right? Which point is getting this new x? Which point is getting this new y? We need to know that. And that's what self does, right? So in this case, our point constructor, now we're adding a little bit to it where we're going to take in a new x and a new y value. So we can create a point at a custom xy location. With an attribute, we're going to set the value that we pass into our constructor to the attribute. And the attribute syntax is self.x and self.y. So x and y are our point attributes. And for any given point, they're going to be set up to be the value new x and new y, right, when we call it. So if you look at the example at the bottom, the point p, right, passes in the values of 50 and 100, right, which become the new x and the new y, which then gets set to be the attributes of the point. Right? And that's kind of the formula for attributes, right? You pass in values and they get assigned to the instance variables. So you can construct your object at different points, right? And so when you see this now visually, right, P and Q no longer are at the origin point, right? They've been customized because the constructor has constructed them at their custom positions, right? So P is at 50 and 100, Q is at 3 and 7. Now, methods are the behaviors of a function. Um, Now, these are not automatically invoked. These need to be explicitly invoked on a point object. But we're defining them generically so that they're going to work for any given point. So, for example, right, just to relate this back to what we did with turtle, if you had a turtle named Tess and you told Tess to go right 90, that one turtle Tess would turn right 90, right? And you explicitly told it, using this dot notation, I want you, Test turtle object, to turn to the right. Um, and then it did it, right? Because turtles are built with that behavior, right? That they can turn right. Um, so methods, like I said, are accessed using this dot notation. That's going to be the same when we use our own custom methods. The self parameter exists for methods, just like we talked about for constructors. And docstrings should also be used, right? So our example here is for a point, you might have two methods defined to get the values of the x and y coordinates for a point. So you could return the instance variables x and y for these two methods, getX and getY. So to use that then, we would construct a point at whatever location. So in this case, 7 in the x direction and 6 in the y direction. Those arguments are passed into the constructor, right? If we look back, constructor sets them to be self.x and self.y. Right? Now when we call getX, p.getX, this attribute self.x is accessible anywhere inside this class point. Right? It's scoped to the class, so we can return it. We can just say, okay, if you decide to get x, I'm just going to return the x value for the point. Right? Same for y. All right. So back to our Replit project then. Right? To finish up this set of notes, we're going to go ahead and define our own custom method talk here. Just like defining a function, it'll look very similar. Defining a method. Right? Let's actually define what a method is again here. So it's going to be written and it's going to behave just like a function. Notice what differentiates it is it's like inside our class, right? It belongs to our class. The difference is that, except that it is invoked on a specific instance of our class critter. So here's here's this self parameter again. So if we want to make our critter talk, we need to know like which critter is talking, right? Because we're defining this generically. So when we say dot talk, we need to know what critter we need to make actually talk. And that's why we must have the self parameter as a reference to the object, to the object that is actually calling the method. Right, so one thing you can do is just to, if this is confusing, the self is confusing to you, just ask yourself this question. So ask yourself, which critter is talking, right? If you just think about, right, if we call the talk method, like we're going to do down below here, so when we're going to say, be this critter one, we're going to make critter one talk. When we call this talk method, we need to know which one of our critters is talking. So in this case, we called talk on crit one. So implicitly, it's going to pass a reference. And by a reference, I mean just like which object, like where in this computer can I find this object that's actually talking so I can like make it talk. And that's what self is, right? It's a reference to that. We can choose to use it or not within the method. Um, we just need to know like, who does this method belong to? So it makes the critter say something. So let's make the critter say something. So we'll just print again in this case, just so we can see stuff. So hi. So I'm an instance of class critter, and I'm self.age years old. So now that we've defined that method down in our main method, or main function, we can call methods. So this is an example of accessing the methods of our objects. So crit1 can talk, crit2 can talk. And at this point, they're not very differentiated, right? So we didn't include those extra parameters for the self, for the constructor. We didn't include any information that allows them to be customizable at this point. So every critter at this point is 0 years old. They don't have names or anything yet. Right? They can just talk. And when they talk, they just say their age. Right? So still at this point, our critters are not all that usable. But now that we have these foundations down, we can start building in additional information to them. So one thing I'd like you to pause the screencast and try as a little challenge is to try defining another method. So your own sleep method and practice calling it. Go ahead and pause the screencast now. Give it a shot, see if you can define your own method, and then call it down in the main and get it to work, right? And when you write the sleep method, all you have to do is just print something so you know it's working. Okay, so pause it and see you back in a minute. All right, so you may have written something like this. So I'll go ahead and copy and paste this into project here. So you need to have a new method defined, right? And I said this is the sleep method, so we'll call it sleep. It's a method, so you needed to have a reference to the object that's going to be calling this method. You'll want a docstring, and then I said you could just print, right? So in this case, we'll print some Z's to indicate that our critter is sleepy. To use our method, down below here, make our critter sleep. Means you should be printing. Let's try that again. Indent error on line 32. Let's see what that's about. My indents, make sure this is working. There we go. All right, so yeah, so they both slept. Right? First critter 1, right, and then critter 2. And that wraps up the first set of notes for the um, unit on object-oriented programming.